Swayam Prabha. Digital India. Educated India.
There are so many people to fool you. They have huge ashrams also. Okay, you may not like it, but they do have huge ashrams just to fool you. If you get fooled, that's your problem. Okay, that's why we learn science. Okay, so let's proceed further. Game 2.
Why is the force less near the
Why are they building ashrams? Yeah.
Why is the force less near the
So, it's actually a shell. This is a shell. Okay. The shell, when it is expanding, the pressure is the same throughout, but for it to stretch equally, you need to have a shape that is amenable to it. For example, you could have you have seen a long balloon?
Yes,
Right?
sir.
If you look at the long balloon will have different force per unit area in one direction compared to the other. Okay? And we call it as different stress in two different directions. So it all depends on the size, the material, etc., etc., that you have certain portions where they experience less stress. Okay? More of it we need to analyze and find out. Okay? When the flower lady does not find a sharp edge, what does she do? She has the ground. She will do like this, and you've seen that, no? Right? We do it naturally, right? But if I understand the concept, I can do much better. Correct? Shall we go to game 2? Okay. This is a quiz game. All of you like it. Okay. This is learnings to useful products. I learned this in my 6th standard, 7th standard, 8th standard, 9th standard, 10th standard, 11th standard, 12th standard. You're in 11th standard? 12th standard? Going to 12th standard. I'm already in 12th standard in April itself, sir. Okay. Okay. What happens when ice melts to become water? What happens? Area increases. Okay. Energy. Huh? Volume increases.
The temperature.
Volume increases, huh?
The temperature.
Volume decreases. Yeah, see, never go into the scientific idea unless we know it very clearly. Okay, experiential understanding is the most important thing. After that, all the other things will happen. Less pressure. Density increases, or the volume decreases. Okay, what else do you know?
Temperature remains constant.
Temperature remains constant, correct? What do we call that? Latent heat, correct? You would have studied latent heat, no? They also studied. The temperature remains at 0. Is it only for ice to water to steam, or any other material that you know? Any other material that you know which melts? Which melts? Huh? Mercury is already in the molten state, correct? Something that melts. Huh? Wax. Okay. What's the difference between wax melting and ice melting? Huh? Density. Okay, which means I have to do that experiment to find out. Temperature at which they melt, correct? Temperature at which they melt, correct? Is it higher or lower? is the temperature for wax to melt higher compared to ice? Roughly how much? Any idea? Give me a ballpark figure. Oh no, yeah, not 150. Huh? Okay, give me other materials that you know, day-to-day materials that are capable of melting. Iron. I mean, it's not day-to-day material. No, you see it happening. What is that?
My name is Purushottaman.
Purushottam.
Ice cream melts.
Okay, that's like ice.
It's like
Correct. Butter. Very good. Butter. Ghee is it? Okay, ghee. Day to day, yaar, don't go to metal, yaar. You're not seeing metal melting every day. Chocolate. Chocolate melts, right? Okay. What we see is that there is a difference between wax melting in terms of temperature, perhaps the amount of heat it needs, or in other words, how much time you would need to supply that heat in order to melt it, correct? So Rahul Panikkar was our student here. Together with Chen, they thought, okay, there is this concept that I know. There is this concept that I know. Can I put to use in terms of helping the poor? Helping the poor? Can you think of it? Ice to water, wax to molten wax. I want to now use it so that I can help the society, poor. Yeah, just think about it. You don't have to respond. Think about it. Think about it. Now I'm going to play a video. I want you to watch it. Will you? Yeah? And please do what she says, okay? I think.
Please close your eyes and open your hand.
Wait. Where are those people? They've gone for tea. I need to increase it. Volume is not enough. Volume is high here. Just a second. I think it's okay. Let's see. Okay, go ahead.
Please close your eyes and open your hands. Now imagine what you could place in your hands. An apple, maybe your wallet. Now open your eyes. What about a life? What you see here is a premature baby. He looks like he's resting peacefully, but in fact he's struggling to stay alive because he can't regulate his own body temperature. This baby is so tiny he doesn't have enough fat on his body to stay warm. Sadly, 20 million babies like this are born every year around the world. 4 million of these babies die annually. But the bigger problem is that the ones who do survive grow up with severe long-term health problems. The reason is because in the first month of a baby's life, its only job is to grow. If it's battling hypothermia, its organs can't develop normally, resulting in a range of health problems from diabetes to heart disease to low IQ. Imagine, many of these problems could be prevented if these babies were just kept warm. That is the primary function of an incubator. But traditional incubators require electricity and cost up to $20,000, so you're not going to find them in rural areas of developing countries. As a result, parents resort to local solutions like tying hot water bottles around their babies' bodies or placing them under light bulbs like the ones you see here, methods that are both ineffective and unsafe. I've seen this firsthand over and over again. On one of my first trips to India, I met this young woman, Savita, who had just given birth to a tiny premature baby, Rani. She took her baby to the nearest village clinic, and the doctor advised her to take Rani to a city hospital so she could be placed in an incubator. But that hospital was over 4 hours away, and Savita didn't have the means to get there. So her baby died. Inspired by this story and dozens of other similar stories like this, my team and I realized what was needed was a local solution, something that could work without electricity, that was simple enough for a mother or a midwife to use, given that the majority of births still take place in the home. We needed something that was portable, something that could be sterilized and reused across multiple babies, and something ultra low cost compared to the $20,000 that an incubator in the US costs. So this is what we came up with. What you see here looks nothing like an incubator, looks like a small sleeping bag for a baby. You can open it up completely. It's waterproof. There's no seams inside, so you can sterilize it very easily. But the magic is in this pouch of wax. This is a phase change material. It's a wax-like substance with a melting point of human body temperature, 37 degrees Celsius. You can melt this simply using hot water, and then when it melts, it's able to maintain one constant temperature for 4 to 6 hours at a time, after which you simply reheat the pouch. So you then place it into this little pocket back here, and it creates a warm microenvironment for the baby. Looks simple, but we've reiterated this dozens of times by going into the field to talk to doctors, moms, and clinicians to ensure that this really meets the needs of the local communities. We plan to launch this product in India in 2010, and the target price point will be $25, less than 0.1% of the cost of a traditional incubator. Over the next 5 years, we hope to save the lives of almost 1 million babies, but the longer-term social impact is a reduction in population growth. This seems counterintuitive, but turns out that as infant mortality is reduced, population sizes also decrease because parents don't need to anticipate that their babies are going to die. We hope that the Embrace Infant Warmer and other simple innovations like this represent a new trend for the future of technology. Simple, localized, affordable solutions that have the potential to make huge social impact. In designing this, we followed a few basic principles. We really try to understand the end user, in this case, people like Savita. We try to understand the root of the problem rather than being biased by what already exists. And then we thought of the most simple solution we could to address this problem. In doing this, I believe we can truly bring technology to the masses, and we can save millions of lives through the simple warmth of an embrace.
They saved 200,000 babies, premature babies. Else, we wouldn't have seen those lives, correct? $200,000. They would have made money also, right? This was back about 15 years ago. Of course, the company no more exists now, they have split, etc., etc. But the fact of the matter is, how many of us did not know latent heat? How many of us did not know that wax melts? It is how I connect what I do, what I learn, what I understand to solving the world's problems. Right? That's what we are here for. That's why we get education, correct? Yeah? Right? Okay. What are the takeaways from this? Takeaways. We need to find and prioritize a problem, okay? What are your takeaways? Find the target audience and cater to their needs, okay? Problems have simple solutions, yeah. We are complicating it. Somebody said molecules separate, etc., etc. Unnecessary. Yes, I will understand it better for generalizing. But the fact of the matter is that There are simple solutions available, and the concept that I learned could be directly used. Yeah? What else? What else did we learn from this? How many of you want to be Chens? How many of you want to be Rahul Panikar? RP is now doing AI business now. He is doing very well. It's about 14, 15 years since he graduated. Yeah. Any other takeaway? They weren't biased. Very good. They weren't biased. They looked at that. They now figured out, okay, I can now use some application which will be sustainable, right? Which was not exist. See, incubators were existent earlier. That was not the problem. The problem was it was not reaching remote areas, and remote areas did not have electricity, right? That's the understanding that was necessary for them to create this. Yeah? Okay. Let's see. How many of you have seen this? No? So I'm going to tell you the story. In the highlands of Himalayas, do you know there are possibilities of droughts? In the highlands of Himalayas, do you know that there is possibility of drought? The reason is water flows in summer, no problem at all. But it flows down, I am not able to store water. It's a rocky area, I can't dig a well, correct? And therefore I cannot store water for long, right? Winter is no problem, I'll take ice, melt it, have water available to me, but it is not so in summer, right? So people, about 300 villages in the highlands had to come down to the valley in order to seek livelihood, in order to be able to survive. Okay? It was very hard for them. 300 villages. So somebody like you was looking at, oh, okay, this is a pain for them to come down for 3 months, stay in the valley, pitch tents, etc., stay in the valley, work for somebody and survive before I go back again to the highland. What a life, no? Every time I had to do this. So somebody like you looked at this as a problem and thought, okay, there is a simple solution possible. I have learned this in my high school. And what is that solution? The solution was ice to pass. Enjoy the music also. Creator eyes to pass. This is a famous person who is Sonam Wangchuk. How do you know Sonam Wangchuk? Three Idiots movie, right? Okay. Did I leave it? Oh, here. Any takeaways? Any takeaways? Anything that you observed? Think differently. What is it that he thought differently? Correct. Okay. He had to adapt a solution, a viable solution. And the viable solution was available through his scientific understanding and application. Very good. Now, let's see if it is a common sense experience, common sense that we can use in order to do this, okay? So, you go to a restaurant, okay, where biryani is served hot, mouth is watering, but it is very hot. It's right in front of you. What will you do? Spread it. Why do you spread it? So what if you increase the area? Heat will escape fast. Correct? Okay, you spread out and you get, so it can cool faster. Very good. But I'm a waiter now. I'm a waiter now. From the kitchen, I need to serve it hot, steaming hot. Put the lid. Huh? Yeah, exactly, you heap it. Why? Less surface area. Correct? Very simple. Same common sense idea. One for the waiter, one for the eater. Right? Same common sense idea, which is spread it, increase the surface area. Correct? Now, okay. Let me end with a story here before I ask you questions. The quiz, right? How many? All of you are from Chennai, right? Have you heard of Ice House? No, Vivekananda House. Vivekananda House. When I was a kid, used to be called Ice House. I lived in Ice House, meaning Ice House area, very near Marina Beach. So I used to wonder why it is called Ice House. Was it because a particular person by name Ice built it? Uh, temperature of Chennai is hot, hotter and hottest. And Britishers could not. They kept ice inside. Wonderful. There were no fridges at that time. I cannot make ice over here. If I seek to bring ice from elsewhere, it would have melted. How did they bring ice? So this was a question lingering in my mind. Do you think you can answer my question? Apply salt over it. But still, where do I get ice? Because I don't have a freezer, no. Where do I get ice? I have to go to either Himalayas or my own place, UK. From there, I have to bring whatever I put on salt, etc., it will melt. What shall I do? Yeah, but even then it is possible that it will melt away. It takes about 3 to 4 months for the ship to reach Chennai from Britain, correct? From London or any other place. It takes such a long time, 3 to 4 months. Do you think ice would stay as ice?
Pressure could have been crystallized.
They didn't pressurize. Again, it was tough to pressurize.
They store it in a way such that the surface area of ice is in contact with air is the least.
Yeah, but how is it possible?
Spherical.
Other ice is stored in ice. The ice is kept in a room so that it's isolated from the rest of
Yeah, that's insulation, but insulation is not that much enough.
the ice is stored in the other ice.
Okay, so you're now talking about an engine that never happens. Okay. Good, no, that we know science. Yeah. Yeah. Any idea? It's a very simple, common sense idea that I already know through biryani. It's the same usual vessel, ship that carried this.
They consolidated it.
Okay, so I'll ask you a question so through which you'll answer me. Okay. Let's say I have a square block, cubic block. Let's say 8 by 8 by 8 inches in size. Yeah. Sphere is okay, but sphere is tough to handle, right? So cubic or cuboid is easy to handle. So let's say I have a cube of ice, 8 by 8 by 8 inches. I keep it one side. The other side, I want the same volume to be there. So what I would do is I would have 1 by 1 by 1 cube ice. How many pieces will I need? 512. That many pieces I would have to the left hand side. Right hand side, what do I have? 8 by 8 by 8 ice. The left hand side I would have that many pieces arranged. Tell me which one will melt fast. How many feel 8 by 8 by 8 will melt fast? How many feel that 512 piece will melt fast? Why 512 will melt fast? Wonderful. Surface area, correct? Just like biryani, I had now spread out in such a way that I have more surface area. Correct? Very simple understanding. So if I carry 1 by 1 cubes of so many, or if I carry 8 by 8 by 8 of ice, which one is likely not melt that much? Simple idea, no? Yeah. So what they did was ice of huge size, about 3 times this room was available. Where? On the sea, floating. Nice iceberg. All I needed to do is lug the iceberg towards Chennai. Yes, it will melt, but it will melt slower than the other one. So simple that they could solve the problem. By the time it reached, it would have probably shrunk to probably 1 meter by 1 meter by 1 meter. Doesn't matter, I get at least 1 meter by 1 meter by 1 meter, no? Right? So they brought that, kept it in this, probably it would last for a month or so in that insulated thing, but that's how they did it. The principle was that surface area is reduced. Of course, you can add all the other things to it, which is insulation, etc., 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 so that you can maintain a larger volume that can be lugged. So far, okay? Is this clear?
If it is insulated, how will it cool them?
No. While transporting. No, so this is the story of ice house.
They had an insulator at the time, but they just put the ice in there.
Yeah, but insulation, what insulation could I have had? Probably wood, right? The amount of insulation also was not as great as what we see today. We have invented a lot of materials today. It was not existent at that time. And the concept of ice house was formed primarily because they could bring big logs of ice. Nice story, no? All of them related to melting. Yeah. So we'll seamlessly go to game 3 and see whether we will be like Wangchuk or Jane Chen or RP, Rahul Panikar. Okay. So I want you to think products and I'm going to tell you what it is. Okay. Hot air is less dense and rises up. Hot air balloon, very good. Hot air balloon, very good. That's the first one, popular answer. Hot air rises. I'm thinking products. Chimneys. Chimneys. Oh, sorry, thank you. Ventilators, chimneys, all similar. Air conditioner, not really. Oh.
Heaters are usually installed along the floor.
Heaters are installed. The place where you keep the heater. Where should you keep the air conditioner? Okay. Cyclones. How? Cyclone is an engine. I'll come to ask this question at the end of this session. I'll tell you. Sea breeze, I can take it. Throw. But you have not told me what is rising up. Blow to replace it. Want to catch?
Campfire.
All right. One more. Again, day to day. Just think of day to day. An igloo. Rising. Where is that hot air rises? I don't know if I can buy it. What else? Can't hear you. Crackers. Not really.
Steaming food. Steaming of food, like idli and
Steaming of food.
we boil the water below and steam will rise up and boil it.
Okay. So steam has to go up, is what you're saying. If the steam goes down also, it will happen, no?
The vessel is empty, not the idli directly.
I see. Okay. To a certain extent, I can agree. Okay. Anything else that you have observed? Have you observed this one? Yeah. What is it called? It's called cooling tower. Okay. Basically, like a chimney, right? You want to see a cool product? Cool product? There you go. What is so cool about it? Let's see.